Hello everyone, I am Srisha. I am from CSE AML department. Today's my topic is Keynote separated graph clustering and layouts for human relationship graph visualization. So let us move on to the topic. So first introduction. So introduction to human relationship graphs. Human relationship graphs model social interactions as nodes, individuals, and edge relationships, enabling analysis of social structures. Here we are considering in this relationship graphs, nodes as individuals and edges as relationships. These graphs are inherently complex due to high connectivity, overlapping communities, and dynamic evolution of over time. Visualizing such graphs requires effective clustering to reduce cognitive load and highlight meaningful patterns. Keynode separation enhances interpretability by isolating influential individuals, examples, leaders, hubs from peripheral nodes. These presentations focus on algorithm clusters and layout techniques tailored for relationship graph visualization in AI-driven system. So let us consider an example for the given human relationship graphs. So this is the example we took. Here the yellow colored mark points are called data point and the circular outline circle are called concept. Uh, just now we have discussed that nodes are called as individuals and edges are called as relationships. So here we took an example. So there is not a clear data. This is so here we have actor. In yellow color circles, we have danced, coined, and acronym. Next, we have some genre. This is about some relationship support in human relationships. So here we have some ear, face, actor, genre, postures, etc. So we can see that how the nodes are connected to each other. Graph representation and data structures. Human relationship graphs are represented using adjacency list for space efficiency in sparse social networks. Each node stores attributes such as degree centrality, betweenness, and community label for downstream processing. Edges may be weighted based on interaction frequency, sentiment, or relationship strength. Just now we have saw this is the relationship of movie related and some human relations. And here are some examples that friendship versus professional and also follow versus mutual friendship. The graph is stored as a directed or undirected structure depending on relationship symmetry. Efficient transversal release on hash maps for big O notation of O of one node lookup and linked list for neighbor iteration. Here O of one is also called as time complex best case in time complexity for linear search. So these are the graph data structures. Here we can see that there is an unknown interlink between one and another with some sub-interlinks. And I mean, here we can see that we can connect from one edge to another edge at the end with some middle interlinks. So this is some called graphs with nodes and edges. Next, keynode identification using centrality measures. Keynodes are identified using centrality metrics like degrees, betweenness, closeliness, and eigenvector centrality. Here, betweenness centrality qualifies a node's role in information flow. Eigenvector centrality assigns influence based on connections to other scoring nodes, computed via the dominant eigenvector of the adjacency matrix. Keynotes often act as bridges between clusters or hubs within dense communities. Threshold-based filtering selects top keynotes by centrality score for separation in layout algorithms. These are the keynote identifications using centrality measures. The measures are nothing but degree, betweenness, closeness, and eigenvector centrality. Next, the important thing, the graph clustering, community detection algorithms. First and most, we will discuss about modularity optimization, Newman-Girwell algorithm. It maximizes the factorial of 1 to m by sum, where in total edges and delta is in nanometer delta. Its Liouville method iterability measures nodes to maximize modularity, achieving near linear time complexity. Spectral clustering uses eigenvectors of the Laplacian matrix to the partition nodes into clusters. Overlapping community detection. Example, percolation captures individuals belonging to the multiple social groups. Clustering results are used to group non-key nodes while presenting key node separation for layout clarity. These are called as graph clusterings. Next, we are going to on key node separation strategy. Key nodes are extracted from their original clusters and repositioned in a dedicated visualization layer or margin. The separation prevents visual occlusion and emphasizes the structural importance in the network. A force directed repulsion model pushes key nodes away from the dense clusters during layout computation. Anchor constraints fix key nodes in peripheral or central positions based on their roles. Example, leaders in center, bridges on edges. The separation is quantified using intercluster distance metrics to ensure spatial distinctions from non-key regions. Next, we are moving to the point force directed layout algorithms. These are some types of algorithms where it stimulates physical systems like attractive forces, spring like between connected nodes, and repulsive forces. Repulsive forces are nothing but electrostatic forces between all nodes. They'll stuck up and they'll connect all the nodes from one to another. So they have compared it between with electrostatic. The Flaxman-Regan-Gold algorithm minimizes energy using f of at ring there is something core and where k is optimal distance. Bayes and approximation reduces big O notation is O of n square complexity to O of n log n by grouping distance node into supernodes. Here the time complexity matters. These are some worst cases and best cases. So in best case, time will be decreased, in worst case, time will be increased. So these algorithms make the time complexity less. It will see to decrease the time complexity. Keynotes are assigned reduced repulsion or fixed positions to maintain separation during convergence. Iterative relaxation continues until system energy stabilize or maximum iterations are reached. Hierarchical layout for multi-scale visualization. Hierarchical clustering organized communities into tree structures using agglomerative methods like average linkage, sort linkage, etc. Each level of the hierarchy is laid out using radial or tree-based positioning to show macro to micro relationships. Keynotes appear at branching points or root levels, reflecting their cross community influence. Edge banding reduces visual clutter by routing intercluster connections along shared paths. Zoomable interfaces allow users to drill down into clusters while maintaining global context, and vice versa, keynote anchors. Spectral graph drawing for dimensionality reduction. Yes, the spectral layout embeds nodes in 2D, two-dimensional, using the first two non-trivial eigenvectors of the graph Laplacian. So there is some mathematical background involved in this graph drawing for dimensionality. So that eigenvectors are used in 3D dimensional, but also as well as in 2D dimensional. So the Fidel vector eigenvector corresponding to the second smallest eigenvalue minimizes under orthogonality constraint. The embedding preserves global connectivity patterns and naturally separates cluster along eigenvector axis. Keynotes exhibit extreme coordinate values, making them ideal candidates for spatial separation. Spectral methods are robust to noise and effective for graphs with clear community structure. Dynamic graph updates and incremental layouts. Human relationship graphs evolve over time, requiring incremental updates to clustering and layouts. Incremental line adapts community assignment without full recomputation when edges are added or removed. Keynotes are re-eval using streaming centrality estimators, approximate betweenness, vice versa sampling. Layout stability is maintained using constraint force modules that minimize node displacement during updates. Temporal smoothing interpolates node positions across time space to smooth animation in visualization. So this dynamic graph is also used in animation. Evolution metric for clustering and layout quality. Clustering quality is assessed using modularity, conductance, and normalized mutual information against ground truth. Layout effectiveness is measured by edge crossing minimization, node distribution uniformly, and cluster separation ratio. User studies evaluate precipitated clarity using task completion time and accuracy in identify the keynotes. And finally, we have two that applications and challenges in AI machine learning systems. So there are some applications that's cluster relationship graphs, anomaly detection leverage, and GNNs, graph neural networks, and visual analytics platform integrate Keynote, which separate layout for intelligence and social media monitoring, real-time dashboards in AI-powered CRM systems, and challenges and future research directions. Scalability remains a challenge for exact centrality computation in billion edge graphs, and dynamic keynote detection must balance responsivities with stability to avoid visual flickering, personalized layouts adapting to users' focus, and integration with large language models like LLMS. And future work includes GPU accelerated layout engines and explainable AI for interpreting cluster decisions. So this is about the human representation graphs and challenges faced. Thank you.